Hello. This time we're going to explore examples of functions sharing the same domain and codomain, exactly the same. So I'll take a finite example in this case. So it's going to be a couple of functions going from the set containing 0, 1, 2, 3 to itself. Now we're going to have a representation here indicating in this case, for example in A, that 0 goes to 3, 1 goes to 3, 2 goes to 2, and 3 goes to 2. If you want a picture of this, it resembles something similar to the following. Right? If you want to see this as a blob, the domain, 1, 2, 3, well, and 0 here, right? And then over here, 0, 1, 2, 3, we have that 0 goes to 3, 1 goes to 3, 2 goes to 2, and 3 also goes to 2. In this fashion. What can we say about this function in terms of injectivity and surjectivity? Well, this function is not injective. And we can provide a good reasoning for this. We have that f of 1 is equal to f of 0, which indeed is just 3. But 0 is different from 1. Now, what about surjectivity? Well, it is not surjective. And how can we argue about that? Well, there is no x in the domain 0, 1, 2, 3 such that f of x is equal to 0. In other words, I'm looking at this particular element of the codomain and I see that there is no arrow pointing to it. Right? That tells me that the function that I'm describing here is not surjective. Okay. Now for the second example, right, and I'll provide it as a picture once again. We have the following. We have 0, 1, 2, 3, and on the other side for the codomain I have 0, 1, 2, 3. This is the domain, and this is the codomain. Okay, now where is that 0 is going? Well, 0 goes to 2, as is indicated here in the table. 0 goes to 2. Now 1 goes to 3. 2 goes to 0, and 3 goes to 1. Now, what can we say about injectivity and surjectivity of this function? Well, it is injective. And the reasoning is the following. No two arrows point to the same item. In other words, different inputs are associated with different outputs. What about surjective? Well, it is also surjective, as every item, right, is pointed by something, right, in the codomain. And once we have these two, right, we would say that the function is bijective. Now, this is not the only possible way of encoding this function, right, as in this table. Uh, for this particular instance, we also have another mechanism to describe a rule to compute this function. And it could be like this. I can say that f of x is equal to x plus 2, as I'm dealing with numbers, modulo 4. In other words, I compute the sum and then I record the remainder while dividing by 4. So if I follow this computation, I have that f of 0 is, well, 0 plus 2 mod 4, but that is just 2 mod 4, which is just 2. While f of 1 is, well, 1 plus 2 mod 4, which is 3 mod 4 modulus, remainder. So this is just 3. Well, when I get to f of 2, and that is 2 plus 2 mod 4, but that is 4 mod 4. So when I divide 4 by 4, the remainder is 0. Well, now I have 3 plus 2 mod 4, which is 5 mod 4, and the remainder of this, well, when you divide 5 by 4, the remainder is 1, which is exactly, sorry,